Welcome to a small introduction to laboratory analysis considerations. In this module of the unit, we're going to move on to some of the considerations once we've handed our sample over to the laboratory where we want them to analyze that sample. If we look at this set of pictures down here, we've already talked in previous modules about going out into the field and collecting a sample. We've probably brought that sample back from the field. It's in some sort of sample container, as we can see in the middle there. And what we're now talking about is this arrow towards the right, where we now want to turn our sample into data. Now this data may be concentration of a nutrient or a metal, it may be a number of bacteria, whatever. Typically we need a laboratory to analyze that sample for us. You may do that in your own laboratory, or more frequently these days we would send it off to a registered analytical laboratory and they would provide the information back to us. Whether you're going to do this in your own laboratory or whether you're going to use somebody else's laboratory, it's very important that you understand some key concepts around how you do the laboratory analysis and how you can assure yourself of the quality of that. And that's what this module is about. So if we go back to our guiding framework, we've now moved down, as you can see, a fair way through the general process for undertaking a monitoring program. As I said, we've been out into the field, we've done our sampling, we dealt with that in the previous module, and now we want to turn that sample into data by conducting appropriate analyses on it. Now if we go to the ANZAC guidelines and if we look at chapter 5, that chapter deals entirely with laboratory analyses, and that's the main reading that I'll get you to do for this module. So if we look in there, ANZAC gives us some guidance on the laboratory analysis program. And if we briefly work our way through this, the first point they say is critical for us to undertake is to identify the desired analyses. Now, in completing the last module, you would have noticed that I actually said that in your sampling and analysis plan you should have done that. So whether you're doing that back there or whether you're doing it at this stage is a bit of a moot point. But clearly you need, when you hand your sample over to a laboratory, you need to be able to tell them very clearly what it is you want them to analyze that sample for. You then need to select the appropriate analytical method. And there's a few considerations that you need to take into account there. So it may be that there's only one method that you can use because that method has been specified by a standard or a guideline which you're working to. Or it may be that there are several methods and you need to work through some considerations to work out which of those several methods you're actually going to ask the laboratory to use for you. Now that choice may be influenced by things like the detection limit or the degree of precision or accuracy that you need in your analysis. It may be dictated by cost of the analysis, it may be dictated by the time available. One method may take much longer than another method. But there are a number of considerations and we'll work through those in the module. Having worked out the method, you then need to prioritize the analyses based on the analyte stability. So if, for example, you've decided that you want to analyze this sample for pH, and you know that the pH of this water may well change over the course of 6 hours, then you may need to make sure that the pH analyses are the first thing that is done. Similarly, you may know that if I've frozen my sample at minus 40 degrees Celsius, then I can keep this for several months before I need to analyze it, and so they may get a lower priority for sending off to the laboratory. Very importantly are a wide range of quality assurance and quality control procedures, and we talked about these in the field sampling component, and they are equally important in this laboratory component. And there's a lot of information, a lot of protocols around ensuring that when a laboratory analyzes your sample, they do not introduce errors, inaccuracies, or contamination into the analysis. And so this is a very, very critical component, and we'll talk about that in the module as well. And finally, and this may seem a little self-evident, but you need to record your results. And this is really important, because you not only need to record the finding, but you also need to record the process of arriving at that finding. That's part of the QA and QC that we talked about a minute ago. But it's also very important that you record your results somewhere, that you can go back to those results and check them as you need to. And having recorded and looked at the results, you may then decide that, gee, the results haven't yielded the precision that I was looking for, or there's clearly some problem with that analytical method because it's giving inconsistent results, and therefore that may drive you to go back to change your method and repeat the analysis. Okay, so that framework is the framework that ANZAC suggests, and if you read through chapter 5, you'll also find, in addition to that framework, they provide you with a very comprehensive checklist. And again, I'm putting this here because I cannot recommend to you strongly enough how useful checklists like this are. If you end up in your career being responsible for establishing a monitoring program, then working your way through a checklist like this before you send your samples off to the laboratory can make all the difference in avoiding very expensive mistakes and very expensive inappropriate analysis of data, which effectively yield you nothing out of all your efforts. I'm not going to run through this. What I am going to say is that if we look at these 14 things which ANZAC have suggested you should check off as part of your plan for sample analysis, then really most of these 14 points fall into two parts of that framework that they suggested. The 14 points tend to deal primarily with either selecting the appropriate analytical method or undertaking appropriate quality assurance and quality control procedures. So what do I mean by that? Well, the first one, selecting the appropriate analytical methods, and ANZAC will, if you read that guidance, they will suggest that you need to identify which method you want to use. You might recall this document which I showed you in the last module. This was the Department of Water in Western Australia, their guidelines for water sampling. And I previously showed you a table like this. I think it might have been for metal analysis. But I was pointing out how this table explains what you want to sample, the type of container you need to use, what collection method to use. But one of the really useful things that a guideline like this is doing is also telling you specifically which method to use. So if you look down here in this shaded part, you'll see that they're recommending that if you want to measure a water sample to determine the total amount of nitrogen in it, you should use the persulfate digestion method number 4500NC as described in the American Public Health Association Manual of 1998. And they go on to tell you about some additional stuff. Now remember, I mentioned in the sampling and analysis plan that sometimes you want to include guidelines or standards. This is one of the reasons, because by including this in your sampling and analysis plan, when you get to the laboratory analysis phase, you already know very clearly which method it is you want to use, and you can tell the laboratory that. So the ANZAC guidelines talk a little bit about what type of methods you can use, which methods you should use, and how you might discover those methods and determine which one is most appropriate for you. The second thing that the ANZAC guidelines deal with in detail is the QA and QC procedures, and I'm not going to go through those in detail, but what I've done here is I've listed 1, 2, 3, 4, 5, 6, 7 of the key points that they talk about in their guidance. The first two we've sort of dealt with, but the next 5 are things like data management recording. What is data management recording, and what should a data management recording system be able to do for you? Chain of custody. Again, what is a chain of custody? Why do we need to have one? They talk about reducing errors, and they talk about 2 types of errors: random errors and systematic errors. And these are errors that are introduced by the laboratory into the analysis of the sample. I want you to be able to read and work out what are random and systematic errors and how can we reduce them. They talk about certified reference materials, and I'd like you again to be able to understand what they are and why certified reference materials are useful to us. And the same for blanks. Now, we talked about blanks in field sampling. Well, we can also use laboratory analytical blanks, and I'd like you again to work out what are they and why are they useful to us. Now, as I said, I'm not going to go through all that. I'm going to make you do the work for this, sorry. And I want you to do that by doing 2 things for this module. First is go and read, not chapter 4, sorry, that should be chapter 5. Read chapter 5 of the ANZAC guidelines. And when you've finished reading them, go away and complete the tutorial. And in the tutorial, you'll find a series of questions. I'd like you to answer those questions and bring your answers along to the tutorial class so that we can work through those together. Okay, good luck and have fun.